For almost 50 years, Voyager 1 has drifted through the vast, silent expanse of space. It journeys alone, carrying the hopes and ambitions of our tiny blue planet. When it launched in 1977, no one imagined it would survive this long or travel so far. Yet here it is, a living tribute to the brilliance of human engineering. Voyager 1 has shattered expectations, boldly crossing into the unknown. It's our quiet envoy to the cosmos, a minuscule dot against the endless stars bearing a message of goodwill and a snapshot of who we are. Picture tossing a bottle into the world's largest ocean, only this ocean is the infinite gulf between the stars. Voyager 1 has ventured farther than any creation of humanity, fueled by the slow, steady power of radioactive decay. It sends whispers of information back to us, faint signals traveling unimaginable distances from the edge of our solar system. Voyager 1 is more than just a spacecraft, it stands as a testament to our relentless curiosity. On board it carries the sounds of our world, music from Bach to Chuck Berry, greetings in dozens of languages, a fragment of humanity set adrift among the stars. We always thought its voyage would be a one-way trip, destined to roam the Milky Way for eons. But the cosmos had a surprise in store. Why did we send this messenger into the void? In the 1970s, scientists saw a rare alignment of the outer planets, a chance that comes once every 176 years. This alignment allowed a spacecraft to slingshot from one planet to the next, visiting Jupiter and Saturn in a single mission. Voyager 1 was built for this grand tour, packed with instruments to see, measure and listen. At Jupiter it discovered faint rings and active volcanoes on Io, volcanism beyond Earth for the first time. At Saturn, it revealed the rings' true nature, thousands of ringlets, shaped by tiny moons. After Saturn, Voyager 1's path was altered for a close look at Titan, Saturn's largest moon. This choice meant it would not visit Uranus or Neptune. That was left to Voyager 2. Its grand tour ended, but a new mission began, the Voyager Interstellar mission. Its goal, travel to the very edge of the sun's influence and beyond. Voyager 1's journey became a quest to reach the unknown. It was no longer just a planetary explorer, but a pioneer into interstellar space. The real adventure was just beginning. For decades, Voyager 1 pressed on toward a boundary no one had ever crossed. The heliopause, where the sun's influence ends and interstellar space begins. Scientists watched for signs, a drop in solar particles, a surge in cosmic rays. In 2012, the data confirmed it. Voyager 1 had crossed the heliopause. For the first time, a human-made object entered the space between the stars. It was a profound moment. Humanity had touched the galaxy. Voyager 1 became our first interstellar emissary, the farthest object ever made by human hands. Every day it adds another million miles to its record. Now, over 15 billion miles away, its signals take more than 22 hours to reach Earth. It samples the pristine environment of the Milky Way, a lonely pioneer in the void. Its journey seemed set to wander the galaxy forever, or so we thought. The universe, it turns out, is full of surprises. Voyager's story was about to change. After entering interstellar space, Voyager 1 sent back data about the void between stars. Then, in late 2024, NASA's team noticed something strange. The probe's orientation data was garbled. At first, it seemed like old age, but the anomaly persisted. In spring 2025, the team detected a shocking change in the Doppler shift of Voyager's radio signal. For 47 years, it showed Voyager moving away. Now it showed the opposite. Voyager 1 was coming back. The scientific community was stunned. Nothing in interstellar space should have the power to turn a spacecraft around. Was it a malfunction? Every diagnostic was run, but the data was clear. Voyager 1 had changed direction, rapidly and dramatically. It was as if it had hit an invisible wall or been swept up by a powerful current. The world held its breath. The lonely messenger, our first emissary to the stars, was returning. The question was not just how, but why. What had Voyager encountered out there? The answers would challenge everything we thought we knew. Voyager's return was the beginning of a new mystery. Unraveling Voyager's turnaround was a feat of scientific detective work. The Deep Space Network's giant antennas listened for Voyager's faint signal, billions of times weaker than a watch battery. The key clue was the Doppler effect. For decades, Voyager's signal was redshifted, moving away. Suddenly it was blue-shifted, coming toward us. The magnetometer readings became wild, showing a magnetic field thousands of times stronger than before. Voyager had encountered something powerful and dynamic. The plasma wave system recorded a deafening roar of plasma waves at the moment of the turnaround. By combining these clues, a picture emerged. Voyager hadn't just turned around, it had encountered a structure, something massive and previously unknown. The void was not as empty as we thought. Voyager's data pointed to a cosmic revelation. What did Voyager 1 find in the darkness between stars? The data points to a filament of the cosmic web, the universe's vast interconnected structure. These filaments, made of dark matter and gas, stretch for millions of light-years, connecting galaxies like a cosmic spider's web. Voyager 1 appears to have encountered the edge of one of these colossal structures. The probe was swept up by intense gravitational and magnetic forces, redirected like a boat in a powerful current. Its instruments recorded a magnetic field and plasma density far greater than the interstellar average. For the first time, we had direct evidence of the cosmic web's reality. Voyager's data confirmed that the universe is woven together by a grand invisible architecture. It was like discovering a new continent in what we thought was empty ocean. Our tiny probe had touched the skeleton of the universe. The discovery would change astronomy forever. Voyager had returned with news of the largest structure in creation. Voyager's turnaround and discovery electrified the world. For a moment, everyone looked up at the sky, captivated by the story of a lonely explorer returning from the unknown. Scientists were astonished. Cosmologists who had modeled the cosmic web were vindicated. Dr. Elena Petrov called it the discovery of a generation. It's like drawing a map and then having an explorer confirm it exists. The data was made public, sparking global collaboration. Artists, musicians, and writers found inspiration in Voyager's journey. The idea that we are connected by a vast, invisible network resonated deeply. It made the universe feel less empty, more meaningful. The forces that turned Voyager around were a humbling reminder of the cosmos's power. For all our knowledge, the universe still holds immense mysteries. Voyager's shocking return reminded us that great wonders remain to be discovered. The cosmos can still surprise us in profound ways. Voyager's story became a symbol of hope and curiosity. Its journey inspired a new generation to look outward. What does this discovery mean for our future? For the first time, we have a map, cosmic superhighways to guide future missions. Interstellar travel is no longer just a dream, it's a tangible engineering challenge. Understanding the cosmic web is key to unlocking the universe's secrets. Voyager 1 has given us our first ground truth, inspiring new telescopes and probes. We now have a new cosmic geography to explore. Voyager's legacy is twofold: our first step beyond the solar system and the mission that revealed the universe's true structure. Even as it journeys back, battered and old, it remains a pioneer. Its faint whisper continues to teach us. Voyager's story is our story, a curious species reaching out, discovering its place in a grand interconnected universe. The journey continues and the cosmos awaits.